Hi, I'm Katie Miller, and today we're going to be doing the first part of Exam 3 for Transport 1, and we are going to be proving the solutions to the uniaxial time-dependent heat diffusion equation with no heat generation. And so the equation that we have for the heat diffusion equation is the derivative of temperature over the derivative of time equal to alpha times the second derivative of temperature over the second derivative of position. And so this alpha right here is our thermal diffusivity. And what we want to prove is that e to the I k x times e to the negative alpha k squared t is a solution for this equation here. So what we want to do is we're going to set this equal to t, and we are going to substitute it in. And so when we substitute this in, when we take this derivative, the dt always comes out. So what we're left with is the derivative of this term, because this depends on t and this doesn't, so this will just stay as it is. So what we end up with is negative alpha k squared times e to the negative alpha k squared times t times e to the I k x. And then on this side, if we take the second derivative of this part, we are going to see that we only have to deal with this term because this term only depends on time and this term depends on position. And so when we take that out twice and we derive it twice, we get I squared and k squared. So what we're going to end up with is alpha times e to the negative alpha k squared times t times I squared times k squared times e to the I k x. Oh, that does not. And so this I squared, we've seen it before in various math classes, and what this is the imaginary number squared, and what that actually is negative 1. And so if we rewrite this a little bit, we will see that it equals negative alpha k squared, just bringing that over here, times e to the negative alpha k squared times t times e to the I k x. And if you notice, that is the exact same thing that we have over here, and since they are equal, that means that this is a good solution.